Let us solve this problem after deriving that mirror formula. You must be aware of all the sign conventions. The application of sign conventions I am going to deal in the next video also. But since this video ends in a shorter time, let us spend some time in solving this problem. An object is placed at a distance of 8 cm from a concave mirror of focal length 2 cm. Find the position and nature of the final image. Now the concave mirror, usually I will, since this is a first problem, I will give more importance to how to solve this. What are the things that has to be taken care when you solve different problems? First of all, you have to take a concave mirror and you have to write the focal length as 2. Now every time when you write the value, you must be very careful whether it is plus or minus depending on the sign convention. So as usual, I said in the videos, you have to take a concave mirror such that you should see the ray of light coming from the left towards the right, so that it is in the plus x-axis. Now place the object at a distance of 8 cm. So and before that you mark the focal length, that is 2 centimeters, and this is F, and our center should be at 4 centimeters. Okay, let it be. Now if you incident parallel rays to this mirror, after reflection they meet at focus. So I'll divide the whole system, this diagram, into coordinate system. So I will take a y dash axis, x dash axis. All the things that come under this direction are positive. All the things, because pole is here, everything that you measure to the right of the pole, positive, left of the pole, negative, and above the principal axis, positive, below the principal axis, negative. So follow the same sign conventions. Okay, you shouldn't go even a little bit beyond your sign conventional decision. Okay, now start from the pole. If you want to measure focus comes here, it is negative. So I will list the values. Focal length minus 2 centimeter. And object is placed at 8 centimeters. 8 means it is not even the double. 4 times 2 centimeters. So it should be away from the center. This is u, and u is equal to minus 8. You will understand why it is minus 8. Because if you keep the object here, you have to measure the object distance starting from the pole and walking towards this side, which is opposite to the direction of incident light from the object. Remember, light is always coming from the object. That light which coming from the object and incident on the mirror must be taken. Sir, is there any ray of light going like this, like this, like this? Yes, there are rays of light, but they don't reach the mirror. They don't contribute to the formation of image. Only the rays which move to the mirror and gets reflected, they form the image. So this ray of light is moving to the mirror along plus x-axis. So you will have to measure the object distance from the pole opposite to the direction of ray of light. So it is taken as negative, minus 8 centimeter. Okay, let it be. Now, so you have the mirror formula. 1 by F is equal to 1 by U plus 1 by V. So this is the formula, and magnification is equal to height of the image by height of the object, that is equal to me minus V by U. That's what we have derived just now. Now, substitute the values. 1 by focal length, actual focus comes here. In a concave mirror, actually the rays of light meet. So that comes to the left, minus 2. So, sir, won't you convert all these things into meters? If you want, you can convert it, no problem. Since this formula involves distance. Suppose this is in millimeter, this will be in millimeter, this will be in millimeter. Make a common unit everywhere. Okay. So I will take everything in centimeter. What the image distance I get? It should be in centimeter. Okay. 1 by F is equal to 1 by U minus 8 plus 1 by V. Now in a concave mirror, image is formed here. In this case, we have seen this in this derivation. Image is formed somewhere here. So you should get image distance as negative, because image is formed here, and the image distance is also measured from the pole to this direction, which is opposite to the incident light. All the distances measured in the direction of incident light are taken positive. Distances measured opposite to the direction of incident light are taken negative. So V should be negative. And remember, we take positive and negative values for only those data given. Given data we use plus and minus. What the answer you have to get, that should come as it is. So now we should get V negative. We shall see whether it is negative or not. 1 by minus 2 plus 1 by 8 is equal to 1 by V. So I will take 8 as common denominator. No calculator required here. Only brain is enough. Minus 2. So if you have brain, use it. Plus, oh no. These 2 4s are, so minus 4 and 8 ones are plus 1. That is equal to 1 by V. Am I right? I have a brain, but I don't know whether it's proper or not. Minus 2 4s are minus 4. And 8 ones are 1. Yes, correct. That is equal to minus 3 by 8. That is 1 by V. So what is V equal to? V is equal to minus 8 by 3. Okay, whatever it is. Minus 2 point. Almost 6666, right? Yeah. 7 I write centimeters. 2.67 centimeters. So it should be between 2 centimeter and 4 centimeter. See here. 2.67, what the answer we have got. They say when in the derivation we have seen when the object is beyond C, image is between C and F. So it should C is F is 2, C is 4. Double this. R equal to 2F. You know that derivation. 2, 4. So between 2 and 4, that answer is correct. Greater than 2, less than 4. Now what is magnification? How do you find out the magnification, sir? Magnification is height of the image by height of the object, or minus V by U. Now suppose in this problem, height of the object is given. Say, I have not given in the problem. Say height of the object is, say some 10 centimeters. What is the height of the image? What do you call H dash in the formula? That's what you have to find out. Okay, we will apply this. First of all, we will find magnification. You see, magnification should be negative. Can you tell me why? Because it is height of the image by height of the object. Image is inverted. Always, if magnification answer what the numerical answer you get is negative, it does mean that image is inverted. If you get magnification answer as positive, that means that image is upright. That is erect image is formed. If inverted image is formed, automatically you get magnification negative. Of course, we will calculate it here. It is inverted, we should get negative. M is equal to, I will use this formula, minus V by U, because we know all the data. What is V? V, I will use it as minus 8 by 3 only, okay? Because it is formed in this side, on this side, minus 8 by 3. So V minus in this formula, minus same in the formula, into V is minus 8 by 3, because we got the answer minus 8 by 3. You can see it here. Here is the proof. Minus 8 by 3 divided by U. U is again negative. It is minus 8. Minus 8. So what is this? Magnification is this minus gets cancelled, but formula minus remains minus 8 by 3 into 8. Am I right? This 8 comes here. And this 8 gets cancelled. Magnification is minus 1 by 3. What do you mean by this? The answer says that image is 1 by 3rd of the size of the object. It is diminished image. So image is 1 by 3rd of the size of the object. How do you conclude it, sir? You take this case, that is H dash by H. This we will take. So magnification is H dash by H, and that answer got is minus 1 by 3. H dash we have to find out. Of course, you should get it as negative. Height of the object, H, that is taken as 10. That is plus 10. Can you tell me why it is plus 10? It is above the principal axis. So plus 10 is equal to minus 1 by 3. Okay, minus 1 by 3. H dash is minus 10 by 3. Of course, H dash is equal to minus 3.333 centimeters if this is 10 centimeters. Okay, this is the height of the image, which is lesser than 10. So our answer is correct. So this is how you have to apply the sign conventions. And in the next video, I am going to deal with all the possible cases, because first of all, what I will do is I will keep all the objects and images at particular distances, and then I will get the image formation by considering different rays. Then along with that, I will take a problem also. In each position of the image, where I get the image, each position of the object, where do I get the image? Accordingly, I will do a problem. Whether we get the same answers or not, how to apply this, everything will be dealt. So tomorrow, you will be ready with a pen and paper and a calculator. Okay, of course, tomorrow's problem doesn't need any calculator, but still let it be with you. And we will calculate everything. This is a sample problem how to show you how do we apply the sign conventions. And if you have any doubt regarding this, you can send a SMS message or WhatsApp message mainly for this number. Okay, 94801 98001. And remember, I will answer in my own time. Now I am little bit busy in creating all these videos, but still I can answer, because this is the area where you have to be very careful, and only experience will give you confidence. You know all the three sign conventions very clearly, but if you want to apply it, you must have confidence. You know that all the distances are measured from the pole, distances measured in the direction of light are taken positive, opposite, everything. But while applying, you will be suring, and if you want to apply it with confidence, you have to solve many problems. So this is the first problem we have solved, and this is how we apply it. So be ready with this answer and ideas. Tomorrow I will be solving a single problem for all the positions of object and image. So be ready for it, because tomorrow we have a session of different types of images. And one more problem, I want to fill the gap so that I can make you engaged for 1 hour, because every time I don't get a topic which can be filled for 1 hour. So we will have one more problem here, because sometimes that topics I can't start a new topic, that creates a problem. Okay, yeah, here is a problem. 2 plane mirrors. Can you read it? Right, yeah. Yes, now you can see that. Okay, yes, this is better. 2 plane mirrors are inclined at an angle theta. You see the sentences, a little bit looks very horrible. A ray of light incident on the first mirror parallel to the second, after reflection from the second moves parallel to the first. Find the angle theta. That is angle of inclination of the 2 mirrors. Read it yourself. See, a small smile comes in your face. Try to understand it. Is it like some tongue twisters? Seashells on the seashore. In the same way, we have a confusing factor here. 2 plane mirrors are inclined at an angle theta. A ray of light incident on the first mirror parallel to the second, after reflection from the second moves parallel to the first. Find theta. Okay, read it yourself. I will give you some 30 seconds. Okay, very simple problem. Only the thing is, you should be very calm and you must be able to understand the sentence by sentence. And if you find it very confusing, of course, this is not a theory problem. I assure you 100%, this will not be asked in the theory. Just to fill the gap, fill the time, you will be free up to some 1:15 or so. To fill the time, I did this now. But it is used. Solving these type of problems give many ideas. Your brain will become very sharp. And there is a chance of asking this problem in the entrance exam. This is related to plane mirrors. Now, 2 plane mirrors are inclined at an angle theta. Okay, let us assume that it is acute angle. Let us don't make it obtuse and complicated. If it is not acute, we will see the obtuse case. So, now consider 2 plane mirrors kept at an angle theta. Okay, one plane mirror like this and another plane mirror like this. I will call the plane mirrors as plane mirror 1 and plane mirror 2. Take a ray of light. I will use different colored pens. Psychiatrists say that you have to use different colors so that if students follow it better. Of course, if they are sleeping, they will get colorful dreams, but still, we will try. Yeah, now go to the sentences. A ray of light incident on the first mirror parallel to the second. You have to incident a ray of light parallel to the second mirror, but incident on the first. You see, ray of light incident on the first mirror parallel to the second. We will split the sentences. parallel to the second but incident on the first mirror. Okay, is it so? Very simple. Incident on the first but parallel to the second. And then what about the next one? After reflection from the second, of course, first reflection should occur in the first mirror. But they say after reflection from the second moves parallel to the first. Okay, let it undergo reflection like this. You know, here angle of incidence, angle of reflection must be same, and you have to draw a normal, all those things. But their argument is after reflection from the second, it moves parallel to the first. Okay, parallel to the first means it is like this. Am I right? Am I right? This is correct. A ray of light incident parallel to the second but incident on first. Incident on the first mirror parallel to the second. After reflection from the second moves parallel to the first. So these two should be parallel. Moves parallel to the first. Okay. Yeah. Now this angle is given as theta. What is theta? Okay. Now what we will do is since this is theta, and they have already said that the final ray reflected from the second moves parallel to the first. That means these two rays are parallel. This line and this line are parallel. If this line and this line are parallel, this should be theta. Am I right? That is theta. And always you must know that when a ray of light is incident, this, incident on a reflecting surface, it reflects with respect to the normal such that angle of incidence equal to angle of reflection. If angle of incidence and reflection are same, what about this? Glancing angle, I will call this one. What do you mean by glancing angle? Angle between the incident ray and the surface. Of course, this we don't express it in theory. But still, we will have a name called glancing angle. What about these two angles? If these two angles are same, definitely these two angles must be same. Correct? They must be same. That means, if this is theta and if this is theta, whatever be this angle, okay, here angle of incidence and reflection should be same, but this glancing angle should be same, theta. That should be same. Now you see the first ray of light, incident here. This ray, incident, parallel to the second. Incident on the first mirror, parallel to the second. So this and this are parallel. This is theta, this is also theta. Correct? So this, incident, the first ray is incident to the first mirror but parallel to the second. So this angle should be theta. If this is theta, you see for this one glancing angle is, here is angle of incidence and reflection, but glancing angle is theta. This should be theta. Right? Hope you have followed this. This ray and this ray are parallel. According to the problem it says. Finally the ray moves parallel to the first. Okay, this is parallel to this. Theta, because this angle is already given. They are this is a parallel line, set of parallel lines, bisector. Here are the two angles which are equal. This is theta, this is theta. This is glancing angle, this is also theta. And this one should be equal because these two are parallel. If this is theta, this is theta. For this one it is glancing angle, it is theta. So this is theta, theta, theta. You see this triangle, all thetas. So 3 theta must be equal to 180. Here, what is theta? It is 60 degrees. So this is one type of problem. So this type of solution, it makes your brain sharper, and your brain will understand that, oh, these types of problems may also be asked. So that's how geometry is used here. You should have some idea of geometry also. But very beautiful problem, and maybe asked in the entrance exam also. But that idea is important. I don't assure you that the same way it will be asked. But some idea related to this may be asked. Okay. Thank you. We will meet tomorrow.